In this video, we're talking about some more trig properties, or rather trig functions. That's finding exact values by making a triangle. So our first example here, we're given that the sine of x is 4 over 9, and we want to find the other trig values. So unless you're told otherwise, we're going to assume that this triangle, or the angle that we're talking about, is going to be a first quadrant angle. Okay, so we're going to draw our angle here. You'll always draw the angle with the x-axis as the bottom. Okay, the x-axis is always in there, and the y-axis is normally the vertical part. It's never formed with the y-axis. Okay, always try to draw your triangles with the x-axis as one of the two legs. So sine x is 4/9. That gives us some hints. We know, hopefully we know, that the sine is the y length of your triangle compared to your radius. So if we have our three lengths, x and y and x and y and radius, then the sine value is y over r. Okay, some people learn it that the sine is the opposite side over the hypotenuse. That is extremely true. It's also y over r if we're talking about our letters from our trig stuff. So if we know that the sine is 4 over 9, we know right away that the y side is 4 units and that the radius is going to be 9 units. Okay, so every trig value, every trig fraction tells us 2 of the 3 sides of our triangle. So if we're going to find the other trig values, we have to first figure out what this x length is. So to do that, we of course apply the Pythagorean Theorem. 9 squared equals 4 squared plus x squared. Let's see, some quick little subtraction here. 81 minus 16 is 65, I'm hoping. Yep, 65 looks good. So this side is going to be the square root of 65 units long. Okay, and I am perfectly happy with leaving that as root 65. Okay, and you should be too. Root 65 is a perfectly good number. Yes, it's a little bit bigger than 8, but for our problem, that's the fact that it's a little bit bigger than 8 is not really necessary. So let's leave it like that, root 65, and I'm going to get rid of the second one down there. So our other 5 trig functions are cosine. So we need to find the cosine of the angle. We need to find the tangent of the angle. And we need to find cosecant. We need to find secant. And we need to find the cotangent. And each of these have their own special relationships, 2 different sides of this triangle. So the cosine is the x side compared to the hypotenuse. Sorry, that should be a 65, not a 69. How do I erase? Maybe this is it? There we go. Root 65 over 9. The tangent is the y value compared to the x value, so 4 over root 65. Okay, I'm perfectly happy with that, but some people might want you to write it like this. So 4 roots of 65 over 65. Okay, that's probably a process called rationalizing the denominator, which is good to know, but not extremely important for us right here. I would like to erase this now. Come here, eraser. Anyway, I guess just use a different color. The cosecant is the inverse of the sine, so that's got to be 9/4. The secant is the inverse of the cosine, so that's 9 over root 65. And the cotangent is the inverse of the tangent, root 65 over 4. Okay, so once you know the relationships, these things are pretty easy to find once you can make your triangle. And that's the first part about this, is making the triangle. So here's another example. We're going to do, given the cosecant is 13 over 5, find the other trig values, and we'll do 1 or 2. We won't do the whole entire thing. So cosecant is the r over the y value. So cosecant is the inverse of the sine. So here's our triangle. This is r over y is the cosecant. So that means that the radius is 13 and the y value is 5. So once again, we have to find the x value, and if we know anything about Pythagorean triples, 5 squared plus x squared, we quickly find out that x equals 12. And now we can find your other trig values. Let's just do cotangent for fun. So cotangent is the x value divided by the y value. So 12 over 5. Okay? Pretty nice. Once you know where to make your triangles, the rest of this is pretty easy. So let's talk about this one here. So we know the cotangent is 9 over 2. So once again, the cotangent is your x value over your y value. But we're told that the cosine is negative. Okay, so if we're looking at our unit circle, the cosine, or the x value, is positive here, negative here, and positive here, because these are where your x values are, of course, positive. To the right of the y-axis, they're positive. To the left of the y-axis, they are negative. So cosine is negative in the second quadrant and the third quadrant. But if you'll notice, the cotangent is also a positive value. So cotangent is positive here, and then negative here, and positive here, and negative there. Because cotangent is an x and a y. So up here in the second quadrant, you have a negative x and a positive y, which means you have a negative cotangent and negative tangent. In the third quadrant, we have a negative x and a negative y, which means we have a positive cotangent. So we know that our triangle must be drawn in the third quadrant, because the cotangent is positive and the cosine is negative, which means we have negative 9 as your x value and negative 2 as your y value. So negative 9 over negative 2 still gives you a positive fraction. So now we need to figure out what our radius is. So we apply Pythagoras again. Negative 9 squared plus negative 2 squared equals r squared. So 81 plus 4 equals r squared. So here we have the square root of 85. Oddly enough. Okay, so root 85 is your radius. And so cosecant is what we're trying to find. So the cosecant is the r over the y value. So remember, this is a theta. Sorry, I should have put in my theta to not confuse you. Anyway, cosecant is r over y. So in this case, the radius is root 85. And your y value is negative 2. So root 85 over negative 2 is the cosecant value. The secant value will also be negative. So let's do that one. Secant value, which is r over x, root 85 over negative 9. Okay, so it's important to have the right quadrant so that we have the right values for your other trig functions other than the ones that you're given. Okay, hopefully that helps. Goodbye.